Good day. In this video, we're going to answer additional examples using the distance and midpoint formulas. First example, find the length of the medians of the triangle having vertices A with 2 and 3, B with 3 and -3, and C with -1 and -1. So our goal here is to find the medians of the triangle with these vertices. Let's visualize now. So we have a triangle wherein this is not drawn to scale or in the right direction, just to show that we have three endpoints or vertices. So the first one has 2 and 3. Second one has 3 and -3. Again, this is not drawn onto the right direction or orientation of the triangle, just to show that these are the endpoints, -1 and -1. So what is the one, or what are we looking for? We are looking for the medians of the triangle, meaning ito yung line segment connecting each vertex to the opposite side, wherein it bisects, It bisects the opposite side. Meaning, for instance, ito si A, di ba? This one is B, and this one is C. So, mula kay A, you're going to draw a segment that bisects the side or the segment BC. Also, you will draw a segment from B to AC, wherein it bisects AC as well. And lastly, you will draw a segment from C bisecting AB. So see the pattern? Well, actually, these lines are supposed to intersect. Anyway, the point here is we need to find the coordinates of these points para makuha natin yung distance formula. So we're going to label these points. Okay? Let's label this A sub 1. This is B sub 2. Or B sub 1 as well. Let's follow the same notation. And this one is C sub 1. So in order to obtain each of these, we need to use the midpoint formula kasi nga na-bisect yung mga respective opposite sides. Okay. Let's start with A1. Okay? So the midpoint of B and C, and distance from A. So to get A1, we need to use the midpoint formula for the points B and C. So that's equal to 3 plus -1 divided by 2 for the x coordinate, and for the y coordinate we have -3 plus -1 divided by 2. This one is going to be 3 plus -1, which is 2, divided by 2, which is 1. And then this one is going to be -3 plus -1, which is -4, divided by 2, that is 2. The coordinate of A sub 1 is 1 and -2. Now let's do the same procedure for all of these points. So for B sub 1, we will look for the midpoint of A and C. So B sub 1 is equal to, or the coordinates of B sub 1 are 2 plus -1 divided by 2 and 3 plus -1 divided by 2. And that's equal to 2 plus -1, which is 1, divided by 2, which is 1/2. And then this one, 3 plus -1 is 2, divided by 2, which is equal to 1. So let's simply write 1 here. So the coordinates of B sub 1 is 1/2 and 1. And lastly, for the point C sub 1, we will find the midpoint of the points B and C. So this will be 3 plus 2 divided by 2, and negative 3 plus 3 divided by 2. And we will end up with 5 halves and 0. So those are the points, the coordinates of the points a sub 1, b sub 1, and c sub 1, 5 halves and 0. Let's copy that. So after that, we're going to compute for the length of the medians. The length of the medians is the same with the distance between the vertices and their respective opposite side, no? The respective point from the opposite side. So we will use the distance formula in this case. For the first one, between a and a sub 1, we will use the distance formula. So whichever comes first, it's okay as long as you follow the same. Kung inuna mo si A, yung x-coordinate ni A, uunahin mo rin yung y-coordinate ni A mamaya. So let's use that. 2 minus 1 squared plus 3 minus negative 2 squared. And that's equal to 1 squared plus 5 squared. That's equal to 1 plus 25. So square root of 1 plus 25. And that is equal to square root of 26 units. So that's the length of the median a in a sub 1. So that's the first median. It has the length of square root of 26 units. For the second one, let's compute for b and b sub 1. We will use the same procedure, distance formula, and that's equal to 3 minus 1 half squared plus negative 3 minus 1 squared. That's equal to 5 halves squared plus negative 4 squared. And that will be 25 over 4. You square the numerator and denominator to end up with 25 and 4 plus negative 4 squared, which is 16. And if you're going to simplify that, 25 over 4 plus 64 over 4 to use the same LCD. And then that will sum up as 89, square root of 89 over 4. Or to simplify or rationalize, that's going to be square root of 89 over 2 units. So therefore, ang distance from b to b sub 1 is square root of 89 over 2 units. So the median will have a length of that same number. Okay, next, for c and c sub 1, that's going to be square root of 5 halves minus negative 1 squared plus 0 minus negative 1 squared. That is equal to 3 halves. Oh, wait. No. It's going to add. So 5 halves plus 1 siya. So magiging 7 halves rather squared plus 1 squared. And that's equal to 49 over 4 plus 1, which is equal to 49 over 4 plus 4 over 4, which is equal to 53 square root of 53 over 4, or square root of 53 all over 2. So the length of c and c sub 1 is equal to square root of 53 all over 2 units. So that's how we compute for the medians of a triangle given 3 vertices with coordinates, given coordinates as well. We use the midpoint first to find the point where the median passes on the opposite side of the vertex. And then we use the distance formula to compute the length of the median itself. Next example. Let's find the midpoints of the diagonals of the quadrilateral whose vertices are 0, 0, 0, 4, 3, 5, and 3, 1. We're looking for the midpoints of the diagonals of the quadrilateral. We need to find the diagonals first. So how do we compute for the diagonals? Or do determine the diagonals of these 4 vertices? We will simply plot them on a Cartesian plane to know which of these points are vertices that are adjacent, magkatabi. Yung mga vertices na magkatabi, hindi sila diagonals obviously. Yung mga non-adjacent vertices, sila yung bubuo ng mga diagonals natin. So let's plot. First, we have 0, 0. Then we have 0, 4. And then we have 1, 2, 3. Somewhere here, we have 3, 5. And we have 3, 1 here. Then let's connect those 4 vertices to form our quadrilateral. So it's like a parallelogram or a rhombus. But the point here is to determine which of these pairs are diagonals. So the pair of 0, 4 and 3, 1 is one diagonal, and the pair of 0, 0 and 3, 5 is another diagonal. So we're looking for the midpoints of the diagonals. We will use a midpoint formula. So for 0, 4 and 3, 1, let's label this as D1 or diagonal 1. And for 0, 0 and 3, 5, let's label this as D2 or diagonal 2. So for D1, we will compute for its midpoint. Let's write midpoint of D1. And that's equal to 0 plus 3 all over 2 and 4 plus 1 all over 2, which is equal to 3 halves and 5 halves. That is the midpoint of the first diagonal. How about for the second diagonal? Midpoint of D2 is equal to 0 plus 3 as well, all over 2, and 0 plus 5 all over 2, which is equal to actually 3 halves and 5 halves as well. Meaning, iisa lang ang midpoint ng diagonals nila, implying that these diagonals are bisecting each other, implying that this is a parallelogram. Okay, that's the definition of parallelogram. Diagonals bisect each other, and we can also confirm na yung dalawang, like if we're going to compute for the distance between these 2 points and these 2 points, they are the same. Similar dito sa kabila. But we don't really need to prove that this is a parallelogram. That's just a consequence or something that we can infer or conclude from what we have obtained with our midpoints for each diagonal, which is actually the same nga lang. On to the next example. Let us prove that the points A in 6 and negative 13, B at negative 2 and 2, C at 13 and 10, and D at 21 and negative 5 are the vertices of a square. Find the length of a diagonal. Let's analyze the problem. We need to show that the points here given are defining a square. So let us recall what a square means. A square is a quadrilateral that has 4 sides that are equal or congruent. So all 4 sides are congruent. That's for sure. That's the first definition. And another thing that defines a square, that it has a right angle on one of its vertices. Or in some references, they say that a square has 4 right angles. If we're going to analyze each of these definitions, the first one is actually defining another kind of quadrilateral in itself, that is a rhombus. So sa rhombus, lahat ng mga sides natin ay equal or congruent. Sa pangalawang definition, we say that it has 4 right angles, meaning it is a rectangle by definition. So that implies that a square is a rhombus and rectangle at the same time. So in order to solve this problem or to prove that these points are the vertices of a square, we need to show that the sides they are forming are equal or congruent, and that the angles they are forming are right angles. That's one way. Another thing to note here is that the rectangle by itself, its definition or some properties of rectangles, no, it shows that the rectangle has the same or the equal length of diagonals. Let's make a quick sketch of the comparison of a rectangle with other quadrilaterals. So here is a rectangle. Since these are parallel and each corner or vertex forms a right angle, if we're going to measure the length of each diagonal, it will be exactly the same length. However, if we're going to measure the length for a parallelogram or a rhombus which has a tilted side, there would be a diagonal which is longer than this other shorter diagonal. So a definition for a rectangle as well, or a property of a rectangle, is that its diagonals have the same length. So what can we get from this information that we have? We can say that a square, in order to show that these four vertices are defining a square, we need to show that the four sides they are forming are congruent and that the angles they are forming are right angles. Alternatively, we can show that the diagonals of these four vertices have the same length. Kasi kapag we are trying to prove that these are four right angles, we need to find muna yung equation of the line for each side, no? And that will take a little bit of time compared to our approach, which is to find the measurement of the diagonals and show na pareho lang yung measurement nila. So, gagawin natin dito, una, kunin yung distance ng apat na pares ng sides and show na iisa lang. And next, kunin ang distance ng dalawang diagonals natin and show na iisa lang din ang length niya. Okay, now let's start. Let us begin with A, the first side, A and B. So to find the length of AB, we will use the distance formula. So 6 plus 2 squared plus negative 13 minus 2 squared. That is equal to square root of 8 squared plus negative 15 squared. And that is equal to square root of 64 plus 225, totaling to square root of 289 or simply 17. So, nagkataon na ang ating sum is a perfect square, so 17 yung square root niya. Let's compare that with the others. Kailangan lahat ng mga sides natin ay 17. So, that's for side AB. For side BC, let us use the same distance formula. Negative 2 minus 13 squared plus 2 minus 10 squared. And that's equal to negative 15 squared plus negative 8 squared. That's equal to square root of 225 plus 64. That's equal to square root of 289. And syempre, expect na natin na 17 din siya. Okay, we're good for A, B, and BC. We need to show naman si CD and DA mamaya, no? This is what we're going to do next. Na kailangan 17 din yung distance nung mga pares ng points na yon. For CD, let's use the distance formula. 13 minus 21 squared plus 10 plus 5 squared. And that's equal to square root of negative 8 squared plus 15 squared. That's equal to square root of 64 plus 225, totaling to square root of 289 and 17 nga siya. O last, kapag ito, sure na to, that means all four sides have the same length. And we have proven na rhombus siya. Rhombus pa lang, hindi pa tayo sa square. Okay, last, for DA or AD, 21 minus 6 squared plus negative 5 minus 13 or simply plus minus negative 13 or simply plus 13 squared. 15 squared plus 8 squared, which will also end up with 225 plus 64, which results in square root of 289, which results in 17. Okay, we're good for the first part. All four sides are congruent. Next, we need to show this one. Diagonals have the same length. That's an alternative to finding the angles of these four lines. So yun na lang ang ating gagamitin, since that will also use the distance formula lang. Hindi na tayo lalayo pa ng ating gagamiting formula. So the diagonals here are the alternate vertices AC and BD. So sa AC muna tayo. So for AC, we use distance formula, square root of 6 minus 13 squared plus negative 13 minus 10 squared, and that's equal to negative 7 squared plus negative 23 squared. That's equal to square root of 49 plus 529. That's equal to square root of 578. If we're going to simplify this, we will end up with 17 square root of 2. So it's actually 2 times 589, 289. No? 578 is equal to 2 times 289. And 289 is a perfect square, so we can find the root of this. Magiging 17 yan. Nasa labas na siya. May iwan si 2. Kaya 17 root of 2 ang length ni AC. How about for the second pair? How about for BD? Distance formula. Negative 2 minus 21 squared plus 2 plus 5, or 2 minus negative 5 squared. That's equal to negative 23 squared plus 7 squared. That's equal to 529 plus 49. And that's equal to square root of 578, which is the same. Kasi ito, magiging 2 times 289 ulit siya, which results in 17 square root of 2. So we have concluded na the diagonals have the same length. So since all four sides are congruent and the diagonals have the same length, we can now conclude that this is a square. Therefore, ABCD is a square. And that's our final answer. On to our next example. By using distance formula, prove that the points negative 3 and 2, 1 and negative 2, and 9 and negative 10 lie on a line. So we need to show that the points negative 3 and 2, 1 and negative 2, and 9 and negative 10 are collinear. In order to show that the points are collinear, we need to find the distance between each pairs of these points. And meron natin tayong may papakita na direct sum lang siya. No? So yung distance nung isang pair plus the distance of the other pair will result on the other pair. Parang ganun na magiging result natin, ang expected result natin. So what are we going to do? We are going to use the distance formula between each pair of these points. Let's label them. This is P sub 1, this second one is P sub 2, and ito si P sub 3. So we will step by step, kukunin si P sub 1, P sub 2, si P sub 2, P sub 3, and P sub 1, P sub 3. We need to show that their lengths add up in some way. Sige, let's start with P sub 1, P sub 2. And that's equal to the square root of negative 3 minus 1 squared plus 2 minus negative 2, or 2 plus 2 squared. That equates to negative 4 squared plus 4 squared. That equates to 16 plus 16, and that's equal to square root of 32, which is equal to 4 square root of 2. So 4 square root of 2, itong isa. Next, for P2 and P3, let us use the distance formula. 1 minus 9 squared plus negative 2 plus 10 squared, and that's equal to negative 8 squared plus 8 squared, square root of 64 plus 64. That results in square root of 128, and we know that 128 is equal to 2 times 64, so we can simply express this as 8 square root of 2. Lastly, yung kay P1 and P3. So P1, P3, let's use the distance formula once again. 9 plus 3 squared plus negative 10 minus 2 squared. Kaya naging 9 plus 3 kasi 9 minus negative 3. That's it. And then, that's equal to square root of 12 squared plus negative 12 squared, which equates to 144 plus 144. So, square root of 288 yan, no? And 144 is a perfect square. Again, 2 times 144. Kaya ang result dito is 12 square root of 2. Dito pa lang, we can see that the sum of P1, P2, and P2, P3 is P1, P3. Kasi 4 square root of 2 plus 8 square root of 2 is equal to 12 square root of 2. Therefore, we can conclude that P1, P2, and P3, these 3 points, no, are collinear. And that is our final answer for this item. Next, if one end of a line segment is the point negative 4 and 2, and the midpoint is 3, negative 1, find the coordinates of the other end of the line segment. So we are given here 3 points, negative 4 and 2, the midpoint 3, negative 1, and another point which is unknown. So if you're going to visualize it, negative 4, 2 yung una, midpoint is 3, negative 1, and this is like unknown. So with the coordinates of x and y, no, let the coordinates of this unknown point be x and y, we can use the midpoint formula in reverse. How is that gonna work? So meron tayo kasing given na midpoint na coordinates, so 3 agad yan. That's equal to negative 4 plus x over 2. While the other one, negative 1, yung y coordinate, that's equal to 2 plus y over 2. So it's just the application of the midpoint formula. Binaliktad mo lang siya Instead of the midpoint, which is unknown, the midpoint is given and you are looking for the other end of the line segment. So let us solve for x and y in these two equations. On the left side muna tayo. Let us multiply both sides by 2. So magiging 3 times 2 is 6 is equal to negative 4 plus x. And then x is equal to 6 plus 4, which is equal to 10. So x is 10. Sa kabila, sa right side, we will multiply both sides again by 2. So it will become negative 2 is equal to 2 plus y. And then y is equal to negative 2 minus 2. So y is equal to negative 4. So x is 10, y is negative 4. The point itself has the coordinates of 10 and negative 4. So this is your final answer. This is a very simple problem compared to the others, right? Next, determine whether or not the points 14 and 7, 2 and 2, and negative 4 and negative 1 lie on a line by using distance formula. This you will use the same procedure doon sa kanina, which is to find the distance between each pair that we can form. So if we're going to label this P1, P2, and P3, we will find the distance between each. So let's do that exact procedure. P1, P2, P2, P3, and P1, P3. That's equal to the square root of 14 minus 2 squared plus 7 minus 2 squared. Next, 12 squared plus 5 squared. That's equal to 144 plus 25 equals 169. Square root of 169. Perfect square, si 169. So ang ating sagot is 13. Next, for P2, P3, we will use the same formula, distance formula. 2 minus negative 4, so 2 plus 4 in short, plus 2 minus negative 1 or 2 plus 1 squared. That's equal to 6 squared plus 3 squared. And that's equal to 36 plus 9. 36 plus 9 is equal to 45. And then since 45 is equal to square root of 9 times 5, and 9 is a perfect square, we can express this instead as 3 square root of 5. Okay, for the last pair, P3, P1, we will use distance formula. 14 minus negative 4 or 14 plus 4 squared plus 7 minus negative 1 or 7 plus 1 squared. That is equal to 18 squared plus 8 squared, resulting in 324 plus 64. To simplify, that's equal to square root of 388, which is divisible by 4. So we can express this as 97 times 4. So ang result niya ay 2 square root of 97. Can we find something? Is like 3 square root of 5 plus 2 root of 97 is equal to 13. Actually, if we're going to try different alternatives or possibilities, we cannot really find a sum. These segments are not adding up. So we can conclude that P1, P2, and P3 are not collinear. So the question here kasi is determine whether or not. So it has a possibility na hindi. And that's the case pala. The set of points is not collinear. On to our next example. If two vertices of an equilateral triangle are -4, 3, and 0, 0, find the third vertex. So let us represent it using a drawing. This is -4 and 3, approximately here, and then 0, 0 is right here. So we need to find a point wherein we can form an equilateral triangle with these 3 points. Actually, we have two possibilities. The first one is we can have a point here, and we will form an equilateral triangle. Another possibility is somewhere here. So based on this information, we can have two vertices of an equilateral triangle. So how do we start to solve this problem? First, we need to express that the distance between the first point, this P1, and that point, like P3, which has a coordinate of x and y, is equal to the distance from P2 and P3. So it's going to be like this. P1, P3 is equal to P2, P3. No, kasi nga, we have an equilateral triangle. So yung distance nito dito at yung distance nito dito ay same lang. And actually, equal din yon sa distance nito dito. But we will use that information later. We will focus on that missing point paired with the other points. Other 2 points. Okay, let us express this using distance formula. This will be -4 minus x, which comes from P3, squared, plus 3 minus y squared is equal to distance of B2 and P3. So it's going to be x minus 0, or simply x squared, plus y minus 0, kasi nga origin, which is equal to y squared. So if we're going to expand this, magiging 16 plus 8x plus x squared for the first quantity, plus 9 minus 6y plus y squared for the second quantity. And that's equal to x squared plus y squared. We can now remove the radical at this point. Actually, kahit kanina pwede na, no? By squaring both sides. And this will result in 16 plus 8x plus x squared plus 9 minus 6y plus y squared is equal to x squared plus y squared. Then we can cancel out or combine like terms if it is possible. So si x squared sa left side at si x squared sa right side, we can cancel that out, as well as si y squared. So may iwan sa atin is 16 plus 8x plus 9 minus 6y is equal to 0. And then we can combine like terms again to form 8x minus 6y plus 25 is equal to 0. What is this equation that we formed? This equation defines a line, no? It defines a line kung saan ang distance ng any given point from P1 is the same distance compared when measuring that exact same point with P3. So if we're going to plot a point here and find the measurement between that and P1, that's the same as that same point with P3. Each point in this line will satisfy that condition. So we can find, with this, this information, we can find a set of points that makes this triangle an isosceles triangle. Kasi dalawa ng sides ang equal. Pero ang kailangan natin kunin is an equilateral triangle. So we need to make sure that the length of this should be the same as the length of this. Dapat ito ang length ng bawat side ng ating triangle. So how can we use that information? we will utilize the distance between P1 and P2 na. So let's solve again. So the equation of the line again is 8x minus 6y plus 25 is equal to 0. Okay, let's find the distance of P1 and P2. Distance formula, negative 4 minus 0 squared plus 3 minus 0 squared. So that's equal to negative 4 squared plus 3 squared, which is equal to square root of 16 plus 9, which is equal to square root of 25 or simply 5. So yung length ng side natin, ng bawat side natin should be 5 units long. Here's the information we have obtained so far. Ang line na yun, or yung point na yun rather, should be in the line 8x minus 6y plus 25 is equal to 0. And also, 5 units away from each of these points. So with that information, we can actually get that vertex. No, we can compute for that vertex coordinates. 5 units long. Okay. Given the distance between P2 and P3, kasi yun yung medyo mas maiksi dun sa una, yung meron tayo diba, between P1 and P3 at saka P2 and P3. Let's use P2 and P3 ulit, which has a distance of x squared plus y squared. Yun na yun. Kasi x minus 0 squared plus y minus 0 squared. Yun na siya. We can equate this further with the length of 5 units. So yun na. This equation will help us determine the 2 points. Okay. Actually, if we're going to square this, square both sides, it's going to be x squared plus y squared is equal to 25. And this will draw a circle. What do you mean about that? That circle, centered at the origin, has a length of 5 units. And it is expected to pass by these 2 points, kung saan sila yung mga vertices natin. So we are going to find the intersection, no? Intersection of x squared plus y squared is equal to 25 and the line 8x minus 6y plus 25 is equal to 0. That intersection, no, it will intersect the circle at 2 points, and that 2 points are the vertices that we need. Okay, so how are we going to do that? We will express 8x minus 6y plus 25 in y form. Then we can substitute what we get with that equation with y. So this will become 6y is equal to 8x plus 25. It's like we're adding 6y to both sides of the equation, and then we have flipped the left side and right side, and then we divide both sides by 6. So y is equal to 8x plus 25 over 6. We will use this and this to find the value of x and y. This is quite a lengthy solution, right? Compared to the other items. Okay, but we're getting closer to the answer. X squared plus y squared is equal to 25. Replace y with 8x plus 25 all over 6. So that is equal to x squared plus 8x plus 25 all over 6 squared is equal to 25. And this, we can further express this as x squared plus, using binomial expansion, this will become 64 x squared plus 400 x plus 625 all over 36 is equal to 25. To get rid of this denominator, we are going to multiply 36 to both sides of the equation, which results in 36x squared plus 64x squared plus 400x plus 625 is equal to 900. Combining like terms, we will end up with 100x squared plus 400x plus 625 minus 900 is equal to 0. And that results in 100x squared plus 400x minus 275 is equal to 0. That simplifies, no, that thing simplifies to 4x squared plus 16 minus 11 is equal to 0. How will that happen? We have divided each term by 25. So each of these, 100, 400, negative 275, divisible sila by 25. So it will end up with that. We cannot find the value of x using factoring. So we need to use the dreaded quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. So that means negative 16 plus or minus square root of 16 squared minus 4 times negative 11 all over 2 times 4. Then, this will become negative 16 plus or minus square root of 256 plus this negative 4 times negative 11, which results in positive 176 all over 8. This will become negative 16 plus or minus square root of 432 all over 8, which is equal to negative 16 plus or minus square root of 144 times 3 all over 8. No? 432 is equal to 144 times 3. And then, from that, we can express this as negative 16 plus or minus 12. Kasi nga, 144 is a perfect square. Square root of 3 all over 8. Now, we can split this muna into two terms, which is equal to negative 16 over 8 plus or minus 12 square root of 3 all over 8. Kasi there is no common factor other than 2. Pero pwede mong ilabas si 3 doon sa 12. Sige. 12 over 8. So, negative 16 over 8 is equal to negative 2. Okay? Plus or minus 12 over 8, which is equal to 4 over 3. No? This fraction can be simplified as 4 thirds. Oh, no. Plus 3... No. 3 halves, rather. 3 halves. So, 3 square root of 3 all over 2. So, negative 2 plus or minus 3 square root of 3 all over 2. So, the value of x sub 1 and x sub 2 are the following. Negative 2 plus 3 square root of 3 all over 2. Tapos yung isa, negative 2 minus 3 square root of 3 over 2. Okay. With this information that we have, we can now compute for the value of y. We can substitute the value of x sub 1 and x sub 2 in 8x minus 6y plus 25 is equal to 0. Replace x with x sub 1 and then solve for y. And then replace x with x sub 2 and then solve for y. So you will also end up with two values of y. Since you will be able to solve that quickly using a calculator or manually, so we will simply write the answer of 3 plus 4 square root of 3 all over 2 for y sub 1. And for y sub 2, it's 3 minus 4 square root of 3 all over 2. So again, using the procedure of replacing x with the value of x sub 1 here and solving for y sub 1. And then we replace x again with x sub 2 and then solve for y. That will end up with y sub 2. So here are the values. Then we can sum up the coordinates themselves. So the first point is consisting of x sub 1 and y sub 1. Syempre, this will become negative 2 plus 3 square root of 3 all over 2. Tapos, 3 plus 4 square root of 3 all over 2. That's the first point. Let's label that V1. And then V2 has the coordinates of negative 2 minus 3 square root of 3 all over 2 and 3 minus 4 square root of 3 all over 2. So here is our final answer. On to our next example. Let's find an equation that must be satisfied by the coordinates of any point whose distance from the point 5 and 3 is always 2 units greater than its distance from the point negative 4 and negative 2. So here we have a given equation, or a given point rather, wherein the distance of an arbitrary point, any point, sabi niya, any point, this will be referred to as a point which has the coordinates x and y, and yung distance niya kay 5, 3 is always 2 units greater. So we can use the distance formula right here. Actually, this one is going to be a short solution compared to the previous one, obviously, kasi this will only use the distance formula. So x minus 5 squared plus y minus 3 squared. This is defined, or this expression refers to the distance between that arbitrary point and the point 5 and 3. Is always 2 units greater, so 2 plus square root of x minus negative 4, or x plus 4 squared plus y minus negative 2, or simply y plus 2 squared. And that is the equation actually. This solution, or answer, is already sufficient. However, you can expand this further. You can square both sides, expand each quantity. It's not going to be that simplified. So I will also accept this as the final answer itself. Since this in itself is an equation that compares the distance between x and y and the point 5, 3, at saka negative 4 and negative 2. Next example, number 17. Find the coordinates of the 3 points that divide the line segment from A, negative 5, 3, to B, 6, 8 into 4 equal parts. How do we visualize this? We have a point A and point B. And then, we are looking for the coordinates of the 3 points that divide the line segment AB into 4. So, if we're going to divide something by 4, ano ginagawa natin? Siyempre, una hatiin mo sa dalawa, and then hatiin mo yung kalahati sa kalahati para maging 4 sila. And how do we do that with points or segments given 2 endpoints? We use the midpoint formula. So in this case, we need to find first the middle point, and then given the middle point, we can use that with A, using the midpoint formula as well to find this point, and the center point again with B to find this point. So let's label the points P1, P2, and P3 for convenience. So to find P2, we need to find the midpoint of A and B first. Para makuha si P2, we use A and B, the midpoint of A and B. That's equal to 5 plus 6, negative 5 plus 6 all over 2, and 3 plus 8 all over 2. And that results in 1/2 and 11, 2. Yun na yun. Yun na yung coordinates ni P2. 1/2, 11, 2. Next, to find P1, we need to find the midpoint of A and P2. So using this coordinate, 1 half and 11 halves, we will use it in the midpoint formula. Negative 5 plus 1 half all over 2. At saka 3 plus 11 halves all over 2. And that results in negative 9 fourths and 17 fourths. So, negative 9 over 4 saka 17 over 4. Tapos, yung last one, yung P3, we will use again the midpoint formula between P2 and B, point B. So, that is equal to 1 half plus 6. 1 half plus 6 all over 2. And 11 halves plus 8 all over 2, which results in 13 over 4 and 27 over 4. So 13 over 4, 27 over 4. To sum up, the coordinates of the 3 points are as follows. Let's write that down again in a larger font para mas kita. P1 has negative 9 fourths and 17 over 4. P2 has 1 half and 11 halves. And P3 has 13 over 4 and 27 over 4. And that's our final answer. For the last item, the instruction is to use the following formulas to find the coordinates of point P. The formula here, although it was not discussed here in the slide, but a brief background of this formula is if we're looking for the distance between P1 and P, the ratio between the distance of P1 and P at saka yung P1 and P2 is defined by R1 over R2. Kunwari meron tayong point na P1 tapos P2. Okay. Kunwari ang ating proportion is 2:3. The idea here is the distance of point P from P1 is twice, no? The distance from P to P2. So it's actually 2:1. If 2 over 3 ang kanya ratio ng R1 over R2, kasi yung distance ng P1 at saka P2 yung ilalim, denominator siya, pero ang distance between P and the respective points ay 2 at saka 1. So parang 2 all over 3. Parang yung 3 is the denominator. Let's give another example on how we're going to represent it. Let's say na meron tayong point that is 4 times. 4 times ang layo niya kay P1 compared kay P3. So, ang idea dito is like ganyan siya. So, 1. Kung 4 times yan, that means ito, ang distance nito kay P1 is like in the proportion of 4. And this one has a proportion of 1. So, 4:1 kasi 4 times. Pero, ang gagamitin mong ratio is 4 over 5. So, you add. Para sa R2, you add 4 and 1 para makuha si 5. That's how we're going to use it here sa ating example. So, let us solve this actual given. The point P is on the line segment between points P1 and P2 and is 3 times as far from P1 as it is from P2. 3 times as far from P1 compared to P2. So this one shall be 3 and this one shall be 1. Ganyan siya. Ang gagamitin natin na ratio dyan, yung R1 over R2 is going to be 3/4. So yung R1 is the proportion itself and the R2 is the sum of the values, no? Sum of 3 and 1. So 3/4 ang kanyang ratio. 3 is to 4. We can use this, no? Ito yung value ni R1, si 4 yung value ni R2, and then plug it in our formula here. Let's use the formula x is equal to R2 minus R1 x1 plus R1 x2 all over R2. Then we can use R2 of 4 minus 3 times x sub 1, which is this one, x sub 1, y sub 1, tapos ito x sub 2, y sub 2. So x sub 1 is 1 plus R1, which is 3, times x sub 2, which is 6, all over R2, which is 4. This equates to 1 times 1 plus 18 all over 4, which results in 19 over 4. So the x-coordinate of our point P between P1 and P2, wherein P1P is 3 times as far as P2P. So P has the coordinates of 19, 4. For the other coordinate, which is the y coordinate, we will use the formula for y. Y is equal to r sub 2 minus r sub 1, y sub 1 plus r sub 1, y sub 2 all over r sub 2. Let's plug in the values. 4 minus 3 times 3 plus 3 times 2 all over 4. That's equal to 1 times 3 plus 6 all over 4, resulting in 9 over 4. So, ang y-coordinate ng P is 9/4. So, this one is the coordinate. No? This is the coordinates of point P. And that's our final answer. So, if you have any questions, feel free to message me in Teams or via Messenger. But here is our discussion of the additional items for the distance and midpoint formulas. These problems came from the book Lighthold Calculus with Analytic Geometry.